let us start today with the introduction to IoT. Okay, I'm going to talk about what IoT is all about and how they play a important role in the current scenario. Maybe a couple of sessions we will touch upon this, and then we will go into some details of protocols which are being used within IoT. Then we will go into the details of maybe in the next few sections. After a few sections, I will talk about the IoT hardware, okay, the device, what all processor architectures are, what is being used as an IoT device. We will touch upon that also so that you understand the whole scenario of where the whole thing belongs to. And when you develop software, you know where it is in each environment it is working. Okay, so what is an IoT? This term was coined sometime back in 99. I'm sure all of you are aware of RFID technology. This is radio frequency identification. Basically, there are two types of RFID technology, passive and active, where we have come across this would have been in a store or wherever you have where you pick up some items and then you walk out. There will be two things will be standing in the front sensors, which will be detecting whether any items you are carrying is built or not. So there are so many technologies, which is one of them is RFID, and which has a built-in receiver transceiver for small transmission of some signal. Okay, it could be passive or active. That means it can be powered internally with a battery, or it could be powered by a radio frequency which is coming from the nearby transmitter. Okay, that is we will talk about those technologies briefly in the coming sessions. I will not go into the details of them now. And then IoT became popular in the time frame around 2020, 10 or 11, and then it came to market in 2014 time frame. I'll tell you the reason why it got so much delayed in coming to the market, though it was conceived way back in 1999. So IoT devices are nothing but sensors and actuators. Sensors are, which all of you are aware, which senses different properties of environment, and actuators are something to operate on or to control some actions or take some actions like motors or speaker or whatever output the IoT device wants to give. That is actuators, and sensors are input to the IoT device. So an IoT device normally can have both, or it could be only one, but sensors are a must. Some way of sensing the environment is a must in all the devices, but actuators could be there or may not be there based on the application for which they have been put across. Okay, but one important thing is they should be connected. They should be connected with not only among the devices in the vicinity, as also with the backend, maybe a server or maybe a cloud. It has to be connected. So normally these IoT devices are connected through wireless because we deploy them in a very unexpected places. But there are possibility that you may have a wired thing, but normally it is wireless. The communication is used for IoT devices to communicate among themselves as well as to communicate with the central server or cloud. Now, these are all evolved from machine-to-machine communication, which were there only in the industrial area. Now it has IoT is an advanced version of machine-to-machine communication, and it is there everywhere. It's not only restricted to industrial areas. It is in all over the place. Now, what is the definition? This ITU is the standard defining body for the telecommunication, International Telecommunication Union. They control all the definitions and protocols and the architecture of different communication equipments and devices, which are expected to work together. The ITU standardization is required because the protocols have to be common, so that any device can talk to any other device, irrespective of who has manufactured it, from which country it has come out from. So ITU controls that across the world, and they have a definition of IoT, which is very popular and very apt for the way IoT is right now. So IoT can be viewed as a global infrastructure. So that's why IoT is coming into play, because they define the global standards, so that irrespective of whichever country the device are manufactured from, they need to be following a standard which is defined across the world. So it's a global infrastructure, IoT, for the information society, because it's basically for exchange of information and the society which works on that, enabling advanced services. So basically, we deploy IoT devices for performing some operations or some services to the users. So it is to perform or enable advanced services by interconnecting. As I mentioned, without connection, the IoT device is useless. It needs to be connected to something. So they need to be connected. There are two things, physical or virtual. Virtual, I will talk about what it is. Physical means the device, actual device which is there. So interconnecting things based on existing and evolving, that means what? It doesn't have to be restricted to only the existing protocols or the versions of protocols, but it should also be in a position to evolve itself. That means you should be, if suppose in 2021 we install a device, and if its lifetime of this device is maybe 10 years, by the time 2020 or 2025 a new protocol comes, or an enhancement of protocol comes, you should be in a position to maybe download some software into this so that it can interoperable with the recent development in the protocol definitions. So it should not be only restricted to existing protocol, as well as evolving interoperable information and communication technologies. Okay, maybe you should be able to upload some other different OS. Right now, it may be having a OS or it may not be, but you should be in a position to uh, make it interoperable even in the future technologies. So this is a definition of IoT by ITU. Now let me talk about what is physical devices, which nothing but the physical objects in the world, and the virtual world is the information world, where the devices which are there physically are developing or generating some information, which is called virtual information. It's part of virtual world, and it could be either dynamic or static, in the sense it may be changing over time, or maybe fixed in terms of sensing and sending the information. So the information could be stale after some time. So we need to make sure that the dynamic information or sensing information that comes from the IoT devices are properly managed. So physical things are the devices which are really doing the sensing or controlling some things around. Examples are industrial robot and electrical equipment. Virtual things are the information which is getting generated, and that need to be stored, processed, and even sent across. Okay, they need to be sent across using the communication technologies, and they need to be processed, and we need to be in a position to access them whenever we want. So that could be a multimedia content, or a pressure sensor, or any other sensing information, as well as any application software which is running in the cloud, which needs this information and then take action on. So all of them fall under that virtual things. So physical and virtual things are actual devices, and then the information they produce, as well as the backend software which is processing the information. Now we are already aware of anytime, anything, any place. Okay, we have mobile all over the place now, and we communicate with each other irrespective of where we are, with the roaming facility that our mobiles have. But what is getting added now is the anything. It's not only that only specific mobile devices or computers on the network can communicate. Now any device, how small it is, it doesn't matter, but they should be in a position to exchange information and receive control information from the outside world, irrespective of wherever they are. That anytime, any place is also there, and then anything also can be in this game, where they are part of this network now. That is what is IoT now. This is the anything portion of our existing communication network is IoT. So the wide expanse of ICT, that information and computer technologies, communication technologies, already provided us with the communication at any time and any place. Now IoT is adding a new dimension to it. Anything can be in a position to communicate with each other. Now, what is the architecture of IoT? Which is a very high level architecture, is similar to what I mentioned. These are all devices and these are sensors. The IoT devices may have sensor or may not have sensor, as I mentioned, but they all need to have a communication. Okay, somewhere they need to be connected. We cannot have an IoT device in isolation and say that it is going to perform something unless it is giving a like a landmine, which is kind of a it's not considered an IoT device, but which is independent. Landmines you might have seen in the war. Even they unearthed some landmines which were landed, put on Second World War. So they only are independent devices which senses the pressure applied on them and explode. So that kind of IoT devices are of no use, and we cannot call the landmine as IoT device also. So now IoT devices have to be connected. They need to have sensors or may not have sensors, but they are connected. Now connection, there could be multiple ways. It could be some device to device, like Bluetooth, where two devices can exchange information without anybody having a centralized one. I will talk about Bluetooth later on. Bluetooth is actually BLE, low power Bluetooth, but I will talk about that in detail later. It also falls under, it's a master slave. At the same time, each devices can communicate with each other directly. Okay, whereas this is the example of direct device to device communication. The B is communication without gateway. Okay, now this is also without gateway. And what is gateway? Let me talk about it. Now, Wi-Fi is a good example of communication with a gateway. All our devices in our home, laptops and mobile, talk to the Wi-Fi router, and then Wi-Fi router in turns connect to the internet. So that's a gateway. So some devices need communication, they do through gateways, or they could also be exchanging information, and then they themselves may be connected to outside world. And as I told you earlier, what is a virtual world, which is information what is generated by these devices. They are captured in this information world, which is nothing but the data which is there in the cloud or maybe in some database representing each of the devices. They are exchanging information because they are all connected, and then they are getting processed somewhere else. So the IoT includes all of them, not only physical devices, also the information part of it, the physical and virtual world. Okay, now why do we call these nodes as intelligent nodes? Because we don't need any human intervention for these devices to communicate. Like mobiles, after you switch on, it becomes intelligent, that it is always connected, but you need to, of course, you have to switch on. Similarly, the nodes should be powered on, but they are intelligent enough when there is no need of communication or there is no active communication happening. They may go into a sleep mode or low power mode and then wake up whenever it is needed, or based on the time and or frequently they will be coming up and then checking things. So it could be many things, though they are intelligent in the sense they are very when to communicate and how much to communicate, how much of power to use. They are all very conscious about the power because these IoT devices are very power constrained environment. As yesterday we discussed that these are all developed by very small microcontrollers which needs very less power, and they are all battery operated. Some devices are placed in the V field for years together. Like if you want to manage a bridge, suppose you have built a bridge, normally the bridges are being manually monitored by people coming around and then checking it. But nowadays they put devices there, IoT devices, which sense the pressure, and then they communicate back whenever some portion of the things need to be serviced or need to be replaced, or we need to be some cracks are there in the bridge. Those things are automatically being monitored using IoT devices. So such devices, their lifetimes are for 10 years or 20 years. So they need to be very conscious about power being used. So it's have to be low power and intelligent nodes. And they communicate through gateway to perform different services, to or offer some services. And what do they contain? They have a small microcontroller and a memory, of course, and some power management, which is very, very important part of IoT. And they also have a communication technology to communicate back. And they collect information from sensor and exchange it. They exchange between the devices as well as to the backend. And normally they do it through wireless communication networks. Okay. Now, there are different, all these terms you might have already come across. Personal area networks, local area network, MAN and WAN, and different technologies which are being used at different levels. Okay, so I am not going to the details of them, but if IoT has to be operational, they should have all this somewhere in the pipeline enabled so that they communicate to the internet. Through internet they communicate with the cloud or with the centralized database, and then they get information from so many places. So they need to be connected, right? Not only among the devices, that it should be also connected at the internet. Through internet they will be connected to the cloud. Okay, now let me any questions so far? Anybody having? It's a general introduction, so I'm not going into details of any technology unless you have something. I'm not seeing. Okay, I'm not seeing the chat box. Let me see. Okay, what is the difference between a sensor and actuator? Okay, very good. What does wake on LAN is supported by Pi? Okay, so Raspberry Pi. Okay, let me answer both. What was the first question? Sensor and actuator. Okay. See, let me explain. Suppose you have a temperature sensor. Okay, temperature sensor, and then suppose maybe I'll assume that you have a hot plate, okay, maybe a food is there, and then you have a sensor there which is sensing the temperature of the, maybe you are heating it with some stove, and then it is connected to some valve which is able to switch on or switch off the gas connection or whatever, so that the stove switches off. It's like if you go into a buffet, you get normally food is kept on a stove and then people come and take it from there. Now if you automate it, the sensor is the temperature sensor which is sensing the temperature of the device, the bowl or the vessel, and then it senses that the temperature is so much and the whatever is the content is boiling. It needs to switch off the stove. So that is to be controlled through a motor or some valve or some relay, so that it switches off the gas connection or stove, so that it switches off this, and then it doesn't get heated up so much. So actuator is this part of it which is controlling. Actuator is something like a physical movement, which actuator will always have a physical movement. It could be a motor or it could be a gear connected to a fan, or rotating or moving. Anything that moves or controls, or a switch. Even a switch is going to be an actuator. A relay is an actuator, whereas sensor is just to sense the different properties. It could be a temperature or heat or pressure or light. They're all sensors. Okay. Now second question is about whether we have a wake up LAN on Pi. See, there is, okay, there may be a different name. It is now, Pi is not meant for that purpose. Okay, as yesterday also I told you, it's not a low power device. Okay, though it is a it's actually power hungry. I won't say it's a low power device because it has got a quad core running at a 2.5 gigahertz or that range frequency. So it's nowhere close to low power device. Okay, whatever I think one of you mentioned about the microcontroller, right? Which is maybe STM32 or some small ARM Cortex based devices. There are low power devices. They operate. Then those devices, if they are connected, normally, you might have heard about power over Ethernet. Okay, power over Ethernet is some devices which are connected to the LAN through Ethernet port gets the power also from the Ethernet LAN connection. Okay, even you have a Wi-Fi, kind of a wired power also is supported. Okay, through wireless, this is wired power. PoE is like a you connect a Ethernet LAN cable to power the device. Whereas wireless also, you can charge some batteries in the device so that it can be wirelessly charged. You might have seen that some mobile devices are now charged wirelessly. Okay, so you can supply power through wireless communication also. PoE is of something which is powering through wired Ethernet LAN cable. Now, what he is asking about is the wake up LAN. Okay, this is about, if suppose some packets arrive in the Ethernet. Okay, see, some IoT devices are supposed to wake up on based on whether any device, anything is communicating with the device, or somebody else is giving a command. They wake up, they go into sleep mode, and then they wake up based on some packets arriving. So that is called a wake up LAN. But Wi-Fi, this Raspberry Pi does not have that. The very low power devices may have that kind of technology, and it could be not only through wireless wired, it could be wireless also. Okay, if any device is addressed, it may be waking up. Now let me, because we are talking about it, let me explain a little bit more. When you say wake up on Ethernet, suppose you have a Ethernet cable connected, or it could be a wireless LAN also, it doesn't matter, wireless. Okay, wireless means, let me call it as wireless. Okay, now what happens is, even if it is sleeping, the device, this is the IoT device, it is sleeping means the core processor, the main core processor may be in a low power mode. That means it may be running in a lower clock frequency, or it is switched off, it is powered off. Because whenever you power the devices, chips are getting, power drawn, current is drawn, and then they dissipate heat, and they consume power. But if it has to sense any communication happening, any packets, network packets coming, there should be some physical devices. This is called Pi. Okay, Phi, it's called Ethernet Phi, or wireless Wi-Fi Phi. Phi is a small device, which is sensing the network. So this will be on, whereas the core ARM processor or any other controller will be off, and they will be sensing the network, and they arrive, if they get a packet, they will collect it, because it is addressed to their its own MAC address. So it will collect the packets and then wake up the core processor so that it comes up. So when the data is arrived, or somebody is giving a command. So this is what is all about wake up on LAN. Okay, wake on LAN. Yeah, PoE is, I heard of PoE used in P2P wireless mostly. Yes. So PoE is, you don't need an additional adapter or power supply to the device. Okay, it is a dual purpose. Okay, when you connect a device with a PoE, power over Ethernet LAN cable, what happens is, this LAN is connected to some router down the line, and when it is connected to the router here, suppose, this router also should have the Ethernet port which is PoE enabled. They say PoE enabled Ethernet ports, and this is also PoE enabled. That sense, the Ethernet cable itself, it's like a wire. Okay, it supplies power to the device, so you don't need any additional battery or additional power adapter, okay, connected to the device. So PoEs are used for such purposes where they need to be connected to the network. Anyway, our IoT devices are always on network, and we use PoE because you don't need more connections to the device. Because if you make why we are going in for wireless communication, because we don't want the devices to be connected through a wire, because it is going to be disturbed, and wiring is a very big headache. When you are installing it in a place, okay, you have to disturb the whole thing. Okay, if it is a concealed wiring, you have to open up everything. So wired devices are not preferred over wireless devices. So, but if you want a wired device, at the same time you don't need a power socket very close to the device, then this PoE will be helpful. Okay, I hope you understand the background of why we use and how do we use it. Okay, if any other questions, I will address them. So we will go back. I don't know, 2 files are there which I was using. Okay, not this. Okay, So let us now talk about reference model. This is also defined by ITU, okay, International Telecommunication Union. How many layers are there? By looking at it, because all of us are familiar with OSI layer, Open System Interconnect, which is 7 layers for network communication. We always associate a layer means it should be one top of the other, but actually this reference model has 6 layers. This is also a layer, though it is vertical. Okay. Now, what are they? Similar to our Ethernet or the network OSI layer, this is the device layer, which is very specific to the communication technology which is being used for the device to communicate with the network. It could be Wi-Fi, or it could be Bluetooth, or it could be Ethernet port, LAN cable, Ethernet LAN, whatever the final communication, or it could be optical cable. So that part of the connection is device layer or physical layer we call in OSI. Then comes network layer, which bothers about what is the, suppose if you have a connected network, different devices are there, and what is their unique ID, either MAC address, or MAC address normally come in the data link layer, which is in between, or IP address. They give a unique address for any device in the network, correct? So that we can be addressed. Any other device can address the another device using that particular IP address. Now that comes at the network layer. You may have a devices connected through Wi-Fi. So like take an example of our own laptops. Sometimes you may connect our laptops with the Wi-Fi router directly with a LAN cable, right? Sometimes we may be away from the Wi-Fi router and we may connect it through a Wi-Fi router or Wi-Fi connection. So the physical layer stops here, device layer stops whether you are communicating through Wi-Fi or you are communicating through a LAN Ethernet cable. But the Wi-Fi device or a Wi-Fi router gives the laptop some IP address, which it can give even if you are connected to a LAN, or even if you are connected to a Wi-Fi connection, it can give the IP address and to communicate with that device. So the IP addresses fall under this network layer area, which is uniquely addressable entity in the network. So we have collapsed different layers here, data link layer and the network layer, even the transport layer, they're all collapsed, and then they simplified it as anything to do with the communication is here, and the device specific things are here. Okay. It talks about Wi-Fi technology and other things here. Actual devices are here. Okay. Now let me give an analogy here. I mentioned about physical OSI layer. So OSI layer talks about the physical connection. Actually, it comes here, Wi-Fi, 3G. They all, even the physical connection is connected here, collapsed here in the network layer itself. Anything to do with the device network is all captured there. Device specific, whether it is a fire sensor or a pressure sensor or a smoke sensor, the device specific information is in the device layer. Okay, little bit different from what you see in the OSI layer. Where in the OSI layer, the bottommost is the physical layer. Okay. Now, service layer is something which I said that IoT device in the isolated area is useless. It has to be communicated, or it should be connected. And it is not enough if it is connected among themselves. It should be connected to the backend somewhere in the cloud or database. So that portion of that part of the service is captured here, the service layer, which is at the backend. It need not be in the same place where the devices are. Okay, they are somewhere else. And then some application may be using this database. It could be one or many. Like you have different applications like smart city, or smart health, or a smart home, whatever. Okay, those are all the applications. Okay, so a device could be used by multiple applications also, and a device can be connected through multiple network technology also, whichever is available. Maybe if Wi-Fi is there, it will do it. Or if Wi-Fi is not there, I will tell you, when I was in Honeywell, we were having sensors which are capable of not only connected to Wi-Fi, they were also connected to the BTS. BTS means our mobile connectivity. That means they have a SIM card. Okay, they have their own SIM card like what we have it in our mobile, so that they can communicate with the base station transceivers, base transceiver station. Okay, that means they have a number SIM card is there which can be identified in the BTS. So it could be like 3G or 4G or 5G, whatever may be. So if Wi-Fi is not there, suppose power outage is there and Wi-Fi is not there, you are having a critical device installed in the industry where maybe a fire hazard is possible. Then you have to be 24/7. It should be connected. So if there is a power outage, this device will have a battery, so it will run, and it will have a BTS because always BTS is powered on, always available. So they will communicate through SIM. They communicate still with the backend. So you have multiple network technologies that could be there in action in an IoT device. Okay. So this is a very I forgot about these two guys. These two are about management and security. This is a very important part. Maybe one session we should talk about. I don't know how much time we'll have, but let us see. This is a very important part of IoT security of the devices, because the thing is the IoT devices have sensors. Not only sensors, they have actuators also. So you can, if somebody with a malintention, they get access to the IoT device, they can do something dangerous to the industry. If it is a health related, if a person is having a pacemaker in the thing, if it is attacked by someone, they can start making the pacemaker to pulse faster, and even the person can die. So that kind of health hazard or even life threatening things are there. So security is more important with the IoT devices also. Okay, so let us just high level overview of these layers. Similar to OSI, two of them are vertical, I already told. Physical or perception layer. Okay, so it's also called physical layer, but it is nothing to do or don't relate it to the OSI network layers. It has a physical things needed. It is talking about the sensors which you have, what kind of IoT physical device, physical world information, the devices you have. They talk about that particular devices in the IoT network. Okay, physical world, the physical devices which are acquiring the data using sensors. It includes both sensor and actuators. Don't think that it is only sensor or the device or the actuator. See, the device is something which is like a processor based controller. Sensor is which is sensing the environment, and actuator is something which is making some changes to the environment. Okay, let me call it as something output. Okay, let me call it as actuators are output, sensors are for input, and the main controller is the processor or a device. Okay, and communication is of course is default, which is supposed to be there. Now, what is a network layer? That captures everything about communication. It provides the networking support and transfer of data over either wired or wireless network. It could be either the packets are coming into the device, IoT device, or it is going out of the device. Both. Okay, both transmission medium and technology are part of this. Okay, that's what I said. It is different from OSI layer, because OSI layer, that bottommost is a physical network layer, but we are not talking about network here. Network is one part of it. Okay, so the complete OSI layer resides here, the physical network, data link, network, transport, session, whatever, application, everything. Maybe application may not be there, session also may not be there, but the remaining OSI layer is part of this network layer. Okay, so don't get confused that device layer is same as physical layer. Okay, they are not. Okay, that's very, very valid point. I should bring it out. Examples include 3G, UMTS, or Bluetooth, Wi-Fi, Zigbee. We will talk about it later on, about each technologies briefly. Now, service layer. See, without this layer, there is no point in having an IoT device installed and connected. They need to have some purpose. So that purpose is being served by the service layer. Okay, what is the use case scenario of a particular IoT device we have installed? So that talks about this. That is all captured in the service layer. In the sense, it maintains the information. More about the application is here. Okay, what exactly they are being used for. But the service layer is to make it possible for the IoT devices to be used by the application layer. Okay, it is a transition between these two. See, this takes care of network layer, takes care of communication. This takes care of the actual device itself, and then this is bridging the gap between what we want to accomplish using the IoT device and what we need from the devices. Not only from a particular IoT device, it can be a connection or a multiple IoT devices. Information is required here so that action can be taken based on the application. Okay. Now, one more important thing here to remember is all of them are expected to work without any human intervention, including the application layer. Okay, it is all automated. The intent is to make them all completely automated. They have intelligence to adapt themselves to different scenarios and take action. Okay, that's how it is. That's why the security layer becomes very important, because they are all in the auto mode. They are all doing what they want to do. That is why even AI is coming now. Okay, so it receives information from the network layer, stores it into the database, processes the information, and can make an automatic decision. That's what I was just telling you. Somehow it is also captured here. They need to be on their own. Okay, we cannot be controlling it. Human intervention is, when you are writing software or when you are designing such systems, you need to assume that they need to exist without any intervention. That means they have intelligence and they need to act according to what they see in the surrounding, okay, or what they receive from the network. Now, application layer, which is in the top. This layer manages the applications dependent upon the information processed in the service layer. So it could be different application, maybe using this database, and then they will be used for different purposes. So the wide range of applications are there. We will not talk about it right now. Smart cities, smart farming, smart homes, many of them. Okay, so let me see whether there are any questions there. I think that makes life easier for all of us. Transport layer of OSI is service layer, or if not, then assembling of segment is done in which layer? Okay. Okay, let me answer that question. See, okay, let me read again. Service layer. Oh, okay. Transport layer of OSI is service layer. No. Okay. See, transport layer. Let me explain in the OSI parlance. Okay. Network, data link, physical. So this comes similar to TCP, right? Transport layer, which is assembling different IP packet. This is IP. This could be Ethernet, LAN. Okay. Now this IP is a connectionless protocol. That means IP packets belonging to a particular data could be split into, this segmentation happens. Okay, when you are sending the packet down, segmentation happens, and then when they are received on the other end, received, reassembly, segmentation and reassembly. So reassembly of those IP packets happen. This is part of the, in OSI, it is part of the transport layer, which is a TCP. A good example of that protocol is TCP. That is captured in the network layer of our IoT. Okay, mostly. Okay, because we are not talking about any network related thing in session layer. Session layer is about database and which are very application specific implementation. Okay, whereas we are only capturing the 3G or Wi-Fi or Bluetooth, whatever we are calling it as, in the network layer, we are capturing all of them. So the transport layer also here, it is all part of that. Okay, we are not even segregating it into that level. Okay, here session layer is for application specific IoT related handling. Okay, I hope this is clear now. It's if not, then assembling of segments. Okay, fine, good. So let us go back. Now how much time we have? 43. Okay, I think I can cover some portion. Okay, now let us see what all we call as IoT platforms. We come across a lot of things like IoT platforms. So let us try to understand where they fit into in the larger scenario. Information from the network layer is often managed with the help of IoT platforms. Okay, what is network layer here? Now, we may use different technologies, and we want a platform, we call this IoT platform, which is kind of a which is kind of a centralized part. I may have a Wi-Fi connection, or I may have an Ethernet LAN cable connection, or even 3G connection. As I mentioned, some SIM card will be there, and then it will be able to communicate with the 3G network. So the IoT device may have everything. Now it could be a device, or I may call it as a IoT platform. Okay, IoT platform means different network technologies may be there, and then I call it as a IoT platform. Many companies provide IoT platform services where they help not only with the data but also enable seamless integration with the different hardware. So now IoT platform doesn't mean IoT devices. Okay, to be precise, IoT platform is something which is at the not at the device level, it is at a higher level. It could be anywhere in the hierarchy. So they help in terms of collating information from different technologies, controlling them, or even commissioning them. Or in fact, even suppose your IoT device, I told you that it should be capable of supporting the future technologies also. In that case, I should be able to download a new software, either protocol software or my own device firmware. Okay, let me call it as firmware running on the devices. It may be another version of firmware I want to download. So those kind of things, if you want to do it not only on one device but across different devices where all it has been already commissioned, they cannot be managed manually. It need to be automated again. So these IoT platforms supported by different vendors, they take care of different they provide these devices also, as well as they provide the platform also, so that multiple things can be managed by them. When you really give it off to customers and then you are managing it becomes a nightmare when you are doing it. So in that time, these IoT platforms will become very handy to take care of those things. And then there are standard software packages which are available for doing that. So they are all meant for seamless integration with a different hardware. It could be not only from the same company, it could be from different hardware also, different companies also. Since they function as a mediator between the hardware and application layer, IoT platforms are also called IoT middleware, that are part of the service layer in the IoT reference stack. So the IoT platforms fall under this category. Okay, they fall under service layer of the reference model. Okay, just to want to map different things on the IoT reference models. So you might have heard about these things. You can click on those things and then learn a little bit about it, so that you understand where exactly these things fall under. And when you read about what they are doing, maybe you will be able to appreciate better this reference model. Okay. Now, how do you choose IoT platform? There are different things. As I mentioned, scalability. In the sense, you may install some few devices. Suppose a big take Reliance. Okay, Reliance stores. Reliance is opening stores all over the places, and they keep on, they want to track what things are getting sold in their stores, electronic, digital, Reliance Digital or Reliance bookstore or whatever. They want to know what all getting sold every day. They want to collect all the information, and then they will be keep expanding the stores. So the scalability of this IoT framework is important because they keep expanding and installing more and more IoT devices, bringing into the network. So scalability is important. Ease of use, of course, it should be manageable with a higher level application or some GUI or whatever with the intelligence. That's why we are coming. AI is coming now because we want to make the use of those IoT platforms easier. Third-party integration. You cannot monopolize the technology area, because you need to be open standard so that any other third-party devices also could be integrated with our IoT platform. deployment options, it should be workable on a broad variety of hardware devices. Okay, so right now maybe no ARM core is popular. Maybe down the line, risk 5. You might have heard about it. Risk 5, new open source, okay, hardware which is designed. The design is available all over. Okay, risk 5 is a good example of Linux. Okay, similar to Linux on the OS side. RISC-V is on the hardware side. See, ARM processor design, what is inside the ARM core, only ARM company knows. Okay, the digital design, what is how going into the ARM core. Whereas RISC-V is another RISC type, reduced instruction set computing. 5 is B, is a new processor technology, okay, which is already becoming popular in the universities as well as in the commercial terms. There are already some open source development boards have come with their thing. The good thing about is, like Linux source code is available for all of us to look at, whereas Windows source code we cannot access. Similarly, ARM design, RTL, the register transfer language, RTL, we cannot have a hands-on. Whereas RISC-V, everything is open. Okay, open source hardware. Okay, design. So deployment option means later on. Right now, ARM core may be there. Maybe it may be replaced after down the line with a RISC-V based hardware. So our IoT platform should be open to getting connected to them. And of course, I mentioned about device security, very important. Data security as well as the device should be secured. Okay. Okay. We are, I don't know, we'll have time for this. I don't want to rush through. So let me open up for questions. Any questions, guys? Okay. What do we do? You said 10 to 15 minutes. So let me, only 3, not much actually. Shall I go through this? Not much. I had planned for more, but at least IoT devices I will complete for 2 minutes if there are no questions. It's very easy to understand. Don't think that it is difficult. A device I already talked about, so that continuity will be there. A piece of equipment with its mandatory capabilities of communication and optional capabilities of sensing, actuation, and data capture, data storage, and data processing. Normally, we may not have a data storage in the IoT devices because they are low power, but that's why I said optional. But communication is a must. Okay. The devices collect various kind of information, share it through communication network. I told already, and then they also execute operations based on the information received from the network. So if actuator is there, they need to be acted upon based on the information comes from the devices. Network. What are the characteristics? They should be interconnected. They should be in a position to be connected to each other. Heterogeneity. Many devices from different vendors, different kind of technologies, they should be able to interoperable. They should be interoperate with each other, or they are interoperable between themselves. They can interact with their own other devices as well as service platforms, IoT platform or backend layer, okay, network, cloud. Dynamic changes. The state of the devices can change dynamically, or they can sleep and wake up, as I talked about. Okay, they can be disconnected as well. Okay, because of power or location, power failure or whatever. So you have to have a mechanism to manage all those things. Okay, suppose an IoT device is there in a environment and it got disconnected from the network. Now it is controlling something. Suppose somebody has switched on the boiler, and then they are supposed to inform through the network that it should be switched off. Now the IoT device got disconnected from the network. Now what should the IoT device do? Should it leave the boiler on forever, or should it control it? So that intelligence should be there in the device, that if I am disconnected with the network, I should take action on my own. So that kind of intelligence, that's why we are bringing AI into the IoT devices. So there can be any number, okay, billions of IoT devices may be there and it's on the network, and they have to be communication, it should be able to communicate. Though they are low power devices, they should be able to communicate with consuming less power. And the communication could be device triggered or from the humans. Okay. So in 2020, there are trillion connected devices with a billion sensors in it. Okay. Or software services. Okay. Billions, trillions of devices with sensors. Okay. So that's the kind of numbers we are talking about. And realize the maximum value from the IoT as a technology, we have to necessarily leverage, integrate programs with other underlying technologies and cloud. Okay, if you want to really make use of these IoT devices, you need to have cloud capabilities also, because the number of devices involved are in terms of billions. That's what I am trying to arrive at. Okay, so IoT devices also done, and we will not go deeper or more longer. It's enough unless you have any questions. Difference between embedded system and IoT. Very good question. IoT is an embedded system. Okay, let me put it as, who is the subset of what? Okay, embedded system is a bigger brother. IoT is a smaller brother, a subsystem in it. Okay, embedded system includes even our mobile phone. We can call it as embedded system. Even our refrigerator is an embedded system, or even a thermo, yeah, motherboard, or sorry, not motherboard. Raspberry Pi is an embedded system, but IoT device is a part of the embedded system which is having some restrictions. One of the very good example of that is low power device. It is a very low power. Embedded system need not be low power. Mostly IoT devices are battery powered, whereas embedded system can be connected to the power. Okay, and normally embedded systems are running on OS. OS will be there for sure. Linux will be there, or Raspbian, or different flavors of OS. But IoT devices are either bare metal. Okay, we call it as bare metal. When a device, a processor runs without any OS, is called bare metal devices. Okay, normally a simpler OS or micro OS, or some low-end OS will be used. FreeRTOS is one good example of IoT devices, whereas you cannot put a Linux running on this. Okay, Linux itself is very huge. Windows is, of course, Windows CE, consumer electronics, Windows flavor may be used, but Linux cannot be used in an IoT device. So this is a definition between IoT and embedded systems. Okay.